Hi guys, welcome to Code Decode. Today we're going to cover some very important Java interview questions for experienced people.
Please like, share and subscribe to support us, and we are setting a like target of 500 likes.
So these are going to be a bit high level, but they are very frequently asked. That how does substring works in Java and how can substring cause memory leak in Java? So you must know the basics before attempting this question that Java is nothing but a sequence of characters. So when you see anything like, let's start code. So if you see anything like string, original string as code, it is not stored like this. Internally, it is stored with a character array as CODE. This is how it is internally stored. So internally, strings in Java is a sequence of characters. String is internally represented by array of characters. So this is array of characters, single character. When a new string object is created, it has following fields. So whenever you create a new string, three things are important. First, the array of characters. That is, these are the array of characters with which the string is created. Then count, that is total characters in a string. So here the count is 4. And offset, that is the start index of offset in character array. So when you created, offset is obviously 0. So that's why your string created is CODE, which is length is 4 and offset is 0. When we take a substring from the original string, a new string object will be created because you know that string is immutable. So when you try to fetch something out of it also, then also a new string object is created, either in constant pool or heap based on how you create it. And the value array, so what is value array? This is the value array, will be shared among two string objects. So how will it be shared? It will be shared between the original and between the substring. So how do you create a substring? Let's see that first. So I'll create a string substring equals to original string dot substring. And I'll start with begin index as 1 and end index as 3. You should know that 1 is inclusive and end is exclusive. So end minus 1 will be your end index till which your object will be created in the substring. So output should be this is 0. This is 1. So it starts from 1. It goes on so on till 2. Because this is 3 minus 1, that is 2. So 0, 1, 2, D should be the last character that is added to the substring. And when you try to print it, OD should be printed. If you try to run it, it says OD. Perfectly fine. Now the question is, how does this substring works internally? So internally, this substring creates a new string. So this is nothing but a new constructor creation with a value array. What is your value array? This is your value array. And what are the other things? Begin index and length. Length is created by end index minus begin index. So the length is 2 and start index is 1. So this is how your substring is created. Now till Java 6, what used to happen is if you have a very big string. So this is a very small string, 4. But if you have a very big string, that is of 10,000 bytes of array, then it will occupy a lot of memory in heap. Now consider a scenario when you just need 2 characters from this big string. Then what you will do? You will just do big string dot substring 0, 2. That is only first 2 letters will be taken from this big string. And since we don't need it, we will make it as null. So suppose this was a big string. You tried to get just 2 letters out of it. And now you want that this original string to be garbage collected. So what you will think is, let me make it as null. So I'll point original string to null. You think it will be garbage collected. Or if you have created with new string code. So where this string will be created? This string will be created in heap area, right? Now when in the heap area, what will be the situation? This is your original string pointing to a heap area, which is a new string code. So this will be some object created with code, string object created, and it will be pointing to it. Now, when you point this original string to null, so this original string will stop pointing here and will start pointing to null. So if this is lost, then no one is pointing here and this will be garbage collected. This is what we will think, right? Our basics. But our basic is wrong here. Why? Because we forget that substring actually shares your value. So when you have created a new substring, that is substring, it is also having a pointer to this new object. So here, not just your original object was pointing to it, but also your substring. So you have created a substring that is also pointing to code. So still it won't be garbage collected because your substring is also pointing to this and your original string was pointing to it. When you pointed your original string reference to null, your substring reference is still pointing to this original string object. And hence, this will not be garbage collected. So we might think that this big string object will be garbage collected as we made it null. But our assumption is wrong. Why? Because when we call substring, a new string is created in memory. But it still refers to the array from the original string. So when we created a substring, still the value holds tight. The array holds tight. Hence, it prevents original string to be garbage collected. And hence we are unnecessarily storing 1000 bytes of memory just for 2 characters. To have a more look into it, if you look at the substring method inside string, so we are already looking to the substring method inside the string, you will figure out that it calls a constructor. So this is nothing but a new constructor that is called with a byte array value. So if you see what is this, it is a byte array value. This is nothing but your original string, and then offset and count is there, is used to create a new string object. What is interesting here is this value array, which is nothing but a same character array used to represent the original string. So what's wrong with this? If your original string is very long, that is size of 1 GB, no matter how small your substring is, it will hold that 1 GB into the memory. And this will also stop original string to be garbage collected. In that case, if it doesn't have any live references, still it holds. So that is why it is a clear case of memory leak in Java. So this is how I can say that even though your original string is not used and you have made it to null, string your substring is pointing and using that particular original string, and hence it is not garbage collected. This is memory leak in Java, where memory is retained even if it is not required. That is the memory leak, right? So that is how the substring method creates memory leak. Every time substring returns a new string, which is not exactly true, it is backed by the same character array. Now, the next question will be, how will you prevent this memory leak? So before JDK 1.6, what you could have done is you could have used intern method. So to prevent this, you can create this as intern. So the problem was because of this substring, right? Because it was still holding the reference to the original string. But if you call intern on it, what does intern internally do? Intern actually creates this substring, that is OD, in the string constant pool. So internally what will happen is, when you create this substring, it will take OD from here in the string constant pool. This is string constant pool, and will create this OD here. And it will stop pointing to this and will start pointing to this. And hence now it is eligible for garbage collection because this object which is in heap is now not being pointed by either original string reference or the substring reference, because substring is now pointing to interned value of this OD. That is, interned value is present in string constant pool and not in heap area. So your original string is capable enough to be garbage collected. So this was what you can have done in Java 1.6. Way to solve this problem is to call intern method on substring, which will then fetch an existing string from pool or create if necessary. So initially we didn't have OD in string constant pool, so it has created OD in string constant pool and return it reference. Since the string constant pool is a real string, it only takes as much space as required. So only now your space required is what needed by OD and your original string can be garbage collected. Now, how does Java itself fix this particular bug? Because this was a big bug in Java 1.6. In 1.7, they have fixed this bug. And how did they fix this bug? They have actually changed the implementation of substring from JDK 7. What did they do? They started invoking substring instead of referring to the character array from the original string. JVM creates a new string with its own array. So I'll show you with a demo, otherwise you won't be able to understand it. So what they have started doing is, in this while creating a constructor and creating a new string, they have started creating arrays.copyof, and this is your character array. So this was code array, and now you are creating a new string. And since you are creating a new string, original reference is lost. Rather than referring to the original array, JVM creates a new string. This is the new string they have created from the array by creating a copy of array. And hence new string object in memory is referred when substring method is invoked. Thus original string is eligible for garbage collection. So rather than you have to do externally intern or anything, internally Java has modified its implementation. What they have done is they have started creating a new string from the array, and not just using the array directly, they have started copying from that array and creating a new string. So that is why the original array is capable enough to be garbage collected. So this is how you can prevent the memory leak. A very important question from interview perspective, what is load factor and hash map? So it's very easy to answer what is hash map, how to get, put or do any kind of operation on hash map. What is difficult is to understand this load factors, capacity, size and these high hole tech terminologies, right? So hash map's performance depends on two things, that is initial capacity and load factor. Whenever we create a hash map, initial capacity is number of buckets that is created initially. So if I say my initial capacity is 8, that means my hash map will contain 0 to 7, that is total of 8 buckets. So this is my initial capacity, that is with which the hash map is created initially. And load factor is the criteria which decide when we have to increase the size of hash map when it's about to get full. So what if I put my object here, here and so on, I fill all my buckets and there is no memory left, then you have to move to a new bucket with double of its size. You have to move to a new hash map with a double of its size. So when will you decide, okay, I'm about to get full, rather than waiting for it to get full, let's create another bigger hash map and move to it. The answer to that is nothing but a load factor. So load factor is the number of buckets that controls the resizing of hash map when number of elements in the hash map crosses the load factor. So for example, if my load factor is 0.75, so this is my load factor, that means this is nothing but 6. So my load factor is 0.75. That means when my load factor becomes 75% of the full size, that is 75% of 8. What is 75% of 8? That is 6. So whenever my buckets are full with till this place, till 5, 0 to 5, that is 6 buckets, I will move this original array to a bigger array and that will be of double size. So that when it becomes 0.75, then resizing is triggered, and what happens inside it is a new array is created and elements of array is copied to the new array. So that is the load factor. Load factor is nothing but a number which decides when to resize your hash map or when you have to move from old hash map to a new hash map by copying all the array elements into the new array copy. Now, how does this resize happens? The resizing happens when map becomes full. So when our map becomes full or it's about to get full, that is when the load factor is reached, or when the size of the map reaches the load factor. For example, if the load factor is 75 and when it becomes more than 75% full, then resizing is triggered, which involves copying of original array data to the new array with of double size. So first the size of bucket is doubled. So if I had the capacity of 8, now this will have a capacity of 16, initial capacity of 16. And then the old entries are copied into the new bucket. Now why I am focusing so much on copying of old elements to new bucket is because we have one more very important question from interview perspective which we're going to cover in the upcoming videos. So just understand this logic first, that what happens when resizing is triggered. Your old data is copied into the new bucket. Now what is the difference between capacity and size of a hash map? So capacity denotes how many entries a hash map can store, but the size denotes how many key or mappings or key value pair is currently present in it. So capacity may be 8, and suppose I have only 4 or 5 buckets filled, then that is the current size. So size is how many key value pairs or entry objects are present currently in hash map, and capacity is how much it can hold. I have so many things more to cover in this video, but the time doesn't permit me. So if you allow me and you like this video, please like, share and subscribe. And please let us know in the comment section if we can move ahead with this series. Thank you.